Okay, so I started teaching before I started recording, so I'm going to fill you in. We have read the example. We have identified the parts here. This is Newton's law of cooling. So T of T is the temperature with respect to time. T of E is the temperature of the environment, which also acts as our vertical shift. T naught is the initial temperature. K is your constant, which is your cooling rate, and T is your time. So we read through, we identified our parts, and we have plugged them in. So now we're going to solve. So to solve, we got to get rid of the extra stuff first. So we're going to move the 16. And then 45, take away 16 is 29. Good.
See, I'm good
And we can go ahead and do this subtraction.
Oh, you can switch it around like that?
Yeah, it's multiplication. So I just put it in an order that's more pleasing to my eye. Alright, and now before we can
Yeah, divide by 80.
solve, we must divide by 80. And it's okay to leave it as 29 over 80. Okay, so this first step has a solving for the cooling rate, the K. So how do I solve for K if K is an exponent?
You bring the exponents out in front.
Log.
When I take the log, that's right. You're going to bring that exponent out in front when you take the log.
Can
And
you just
specifically
write log?
in this example, I'm doing natural log because it is base
E.
E.
You gotta do natural log.
You can
Okay.
just write log E. You don't have to write ln E.
No, you can't.
Because that's when I get
Alright,
confused when you
alright.
start switching up the letters.
Okay, so this gives us negative 4K times ln of E, which is just 1, so we don't have to write it. So our last step would be to divide by negative 4. So our constant that represents the rate at which this egg is currently cooling is this. Now, because I'm going to use this answer to continue with this problem, I do not want to round now. You never round until the end. Because if I were to round now and use this rounded answer and perform more mathematical operations with it,
It would change the answer.
it does. You
Yeah.
take your little bit of error and you make that error bigger. You
Butterfly
compound your
effect.
error, which is not good.
No.
The
So,
butterfly.
yes, ma'am.
Do you want all decimal places or?
You would just leave it just like that.
Okay.
It's a butterfly
Okay.
effect.
So now we know K.
Butterfly
Now we can approach this question. When will the egg reach 20 degrees? So now we want to know not when it's 45, but when will it hit 20?
Miss Willoughby, is it the snowball effect or the butterfly
Could
effect?
be both.
Like, I've never heard the butterfly effect unless we're talking like the
Time travel?
National Geographic documentary called Earth.
Whoa!
Whoa.
Hold on. I got a hand. We'll bring it back. Okay.
Slide to the left.
So this is our K. Now this says E to the negative K. Guys, do you see this has a negative and this has a negative? And what happens to the negatives? They cancel. The opposite of this makes it positive. So E is going to be raised to the ln of 29 over 80. So 29, a little hard to read. Divided by 4 times T.
I'm on the room.
Go to the back.
So now we solve this. Minus 4.
So we're,
Nope, minus 16 leaves 4.
we're just putting that back into the same equation?
Yep, except now we're trying to answer the question they asked us.
Right.
When will it hit 20? So we get 4 equals 80. E to the ln of 29/80ths divided by 4 times T. So then we divide by 80. which is 1/20th, and 1/20th is this exact decimal. So if it's exact, you can write it as a decimal. Yes.
Is this the same problem?
Yeah, we use the information from the first part of the problem to solve this second. When will it hit 20? So we had to take this K,
Oh yeah, you have to find K and then you got
and then you plug in K.
So this takes forever, is what you're saying.
It could, especially if you work slow.
I don't work slow.
Well, then you're good. All right, so now we take the natural log of both sides.
Running polls.
So this comes out in front. And we get natural log of 0.05 equals natural log of 29/80 divided by 4 times t. And solve for t.
All this just to know what a hard-boiled eggs temperature is.
Why didn't we just time it in the first place?
Could be important.
Could save mankind.
Okay,
Got a point.
that's fine.
This will be.
Miss Willoughby can see in her head so much application that is viable.
What does viable mean?
That it can be used for realistic.
Log cooling.
The only problem is every time I share that with you, 80% of my students' faces, 10% of them are always belligerently stubborn. I would never do that. And then 10% get excited.
We know not ever knows in real life if you want to become a math teacher.
Miss Wilby.
Cool.
Is 4/80, the natural log of 4/80.05.
Yeah, 4 divided by 80 is 0.05. Yes, sir.
Where did the negative on the 4 go?
The negative canceled with this negative. See, in the formula, there's a negative right there. So this negative and this negative canceled to make a positive up there.
Oh, okay.
Okay. All right, guys, see if you can punch this in correctly.
Don't have any motivation.
Is it 11?
Yes, it is.
What is that?
All right, 11.8 minutes is our time.
Yeah, pretty sure I was there.
No, the review is going to be a 10-point review grade. And then Thursday and Friday, we have an in-class activity that'll be like a quiz grade.
Yes, it's there, Cole.
If you Charlie solved the negative K.
That bag, that's all. What was that?
Negative K warp. So do you make it
We're
positive
literally
and put it
pushing
in
the
because it's a
roll
negative
thing
K already.
right next to each
Negative K
other.
tells you.
No, you were next to me.
Okay,
We were
I
in
know
the
this
middle.
that
one.
makes sense. But like in the formula that's negative KT, do I?
So it always has
It just says
positive, plug it back in.
it's so positive one plug back in. That's
We're
what I
supposed to go to bed last time, Cole.
Alright. Put it on the room on the sheet.
Oh,
How do you get 11?
Yeah.
Okay,
Does the ln .05 matter a lot?
okay, these have to be grouped right here. Because it's this divided by this. So there's two ways you could do
You
it,
got the
guys.
same amount.
You could do this first, and then do ln of 0.05 divided by the a and s, the answer button. Or you gotta put this extra set of parentheses around that. Those are your two approaches.
I'm sleeping until 5 in the afternoon.
Yeah, that's too.
Oh, I'm totally calling y'all.
I got one. This is like,
Mitch can't sleep until 5 in the
I
afternoon
can't
because he
either.
has a basketball game.
Hold on, these are gonna be different numbers.
I wish I could see that long, but I can't. If I wake up and it's like past 12, I get mad.
Mitch
'cause I
got
wasted my day.
1.24, I got 0.74,
Let's see what's going on.
0.73.
Let me see.
So we may run a
You didn't have your big parentheses around the bottom. So we got to do
yeah, but there really isn't
ln
anything
of
to do for
No,
Zoom.
this section's right.
Just go on.
It's figuring out
ln
the
of 0.05 divided by big parentheses. ln 29 or 80. Low divided by 4.
Okay. Alright. Carrie?
You had to have
Learn
big
something,
parentheses
alright?
around the
Socks are
bottom.
Number, parentheses, what you typed in,
Oh, so it's
parentheses.
There. Your socks are showing.
Got it.
Carrie, I'm curious about I know this was a show. They're called boot socks. I'm looking at Possibly. We got Carrie out. I will again. I will again.
Everybody.
Only one person.
Everybody, you got her.
I
Y'all
got
her.
1.2 points, Louis.
Everybody.
That's wrong.
Bugles used to be the Jones.
You're missing the parentheses.
No
Yeah.
license voters.
Me, please.
Oh, you should have said it. You should have been more specific.
I want, what was I supposed to write?
Jeez, Carrie, I don't know.
That's not true.
Thanks for the fish.
Oh, I think you got one too many right there.
You said it.
I'll wait.
Parentheses. Who is everyone?
Oh, yeah, you're right.
Do I have to go get it for myself?
It gives you one on that.
Alright. Did everybody get their calculators to spit out the right answer? That cares enough to try. Alright, let's move on.
I tried.
Okay, now, number 2 is a little different. Same idea, just a little different. Okay, so,
I know that's.
Are we doing number 1 or number 2?
actually number 1.
T-O.
I'm going to have you set up number 2 when you're in.
Banana bread.
Okay, Claire, can you read number 1 to us?
An aluminum beam was brought from the outside cold into a machine shop where the temperature was held at 65 degrees Fahrenheit. After 10 minutes, the beam was warmed to 35 degrees Fahrenheit after another 10 minutes. Its temperature was 50 degrees Fahrenheit. Use Newton's law of cooling to estimate the beam's initial temperature.
Okay, so, this time we have to work backwards because we weren't given the initial temperature. Okay? Now, there's a couple ways you can do this. The easiest way is to take the first temperature they give you and call that the initial temperature, even though you know it's really not
I almost
the
did
very
that.
first temperature.
I do it.
Okay, so, what is the temperature of the environment?
65 degrees.
65. T of E is 65. Okay. I just instructed you to take the first temperature they gave you and call that T naught. So, what is the initial temperature?
65.
35.
35.
What? I thought 65 was before.
As long as everything's in one unit or the other, just make sure you give your answer in the correct unit. Okay.
I
thought we were finding.
thought the first one was 65.
The temperature that we brought the beam into, the temperature of the environment in which the beam now resides is 65 degrees.
Right.
The initial temperature, the first temperature we were given for the beam is 35.
So for the beam.
Yep. All right, now, given this temperature, it says 10 minutes later, it's 50. So the temperature with respect to time here would be 50. And the time that elapsed between a reading of 35 and a reading of 50 degrees Fahrenheit was how many minutes?
10.
10. So, this T naught is not truly the initial temperature of the beam, but we have to use it to find K. Alright, so let's plug it in. 65 is not first. 50 equals 65 plus 35 minus 65 e to the negative k t.
I wish we could just stop here.
Please solve for k.
Because
Roger that.
We need a magic button that just, you type that in. Is this right?
So,
you know what K is?
This is the magic button right here.
Hey, beer
It takes a
ball.
lot of.
What's the
it's not
initial
just one button
temperature?
though. It's a bunch of presses, and you gotta.
No, she already set it up, dummy. Just sign.
What's the initial
Takes a lot of
temperature?
energy.
My
I-
calculator's
at the
out of
end?
batteries. I had a physics test today.
I wrote it on the board is what he's telling me. The equations on the board.
I know, but I don't have a calculator to plug it in.
You guys didn't want to be on
What's the
button.
constant? If I-
Can you tell us, Miss Willie, what K is? Because
Is that K?
So,
'cause we-
65.
I think that's
K is, for this problem, K is ln of 0.5 over negative
We
10.
can just type in numbers until we get 50.
Wait,
We can just type in random numbers in our calculator until it equals
Mr.
50.
Cola.
I don't think
You
so.
don't have a, you don't have a plus right here.
You'll never
No,
do.
because I can mix that with negative 30 and then I have.
You can't do
five.
You hear me? They would.
This is times E.
No, gotta give us an error.
So do I divide by
You
negative 30?
subtract the 65 and then divide by
I'll do that.
What?
That's okay.
Excuse
That
me?
might work. I did it.
Hey, Mitchell.
Hey, you think we'll be on the field?
Probably not.
Just old news.
Oh, yeah. Don't worry about
As if I care. As if.
Nice class, good one.
Yep,
Alright.
that's the right K.
Get back at me.
So now you gotta use that K and plug back in and do the second part. It's a two-parter. So you pretty much have to start back over with your new stuff.
Okay, but the only thing that's okay.
The K stays the same, the other stuff changes.
I wish I had my calculator today.
We'll be off the trees.
It's because I'm not there yet. I mean, I can show you.
Delicious.
Start back over. Solve for the initial
So
temperature.
it just gets brought up there in the geo. Okay, that's what I was.
What'd you do over there?
Error.
Hold on.
That's step one.
Yeah, it's all
You
that.
can't divide that with
I
it.
didn't put it in the correct order.
Where's your one for this one?
Can I do that?
I put it on the
So
calculator.
You gotta
you guys
divide
combine
that,
it?
you gotta divide by negative 30.
Where's your exponent?
Why do I divide by negative 30?
Because that's how you get it in the right form.
Wait,
Alright.
all we're doing is getting K by itself.
All we're doing is solving for K.
Yeah.
Alright, so let's talk, show you this. Alright, you gotta make the 65,
Try to find.
and we got negative 15 equals negative 30
That's the initial
e to the negative 10K.
initial temperature.
Divide by negative 30, divide by negative 30. So 0.5 equals e to the negative 10K. ln goes away, divide by negative 10. So ln of 0.5 divided by negative 10 is our K. That's our constant.
Wait, can I write it as negative 10K ln? Because aren't you supposed to put the exponent in front of the log?
Yeah. I just got rid of the log altogether.
Josh got hit by it now.
Yes.
So I'm just curious, if we are trying to find the number, doesn't that mean that the time would be 0? And if the time is in the exponent and then the time things times 0 is 0, then did we really need to find k in order to find
That's some conceptual stuff.
Is that ln of e or ln times 5?
If they, your idea is correct if they gave us the initial temperature to start with. Because time would be 0, all of that would go away, and we'd be left with T naught. But we weren't given T naught. So the only way to get back to it is to go through this.
What happened to the 30?
50 and then you gotta put 20.
I divided by it.
You divided
Yeah, okay,
15
you gotta
by
look at the
30
time.
and you got 0.5.
Look,
Yes, 15 over 30 is 1/2.
And then you did
It's outside.
ln of both sides.
Yeah,
We don't have
And
the
then
temperature.
you got ln 0.5 which is negative 10.
Yeah.
Equals what?
K.
And it equals 35.
That's the answer.
No.
Yeah?
Well, then I
That's
don't want to be in
K.
this
No,
class
it's
anymore.
okay.
Okay,
So,
alright. So now we found our cooling constant. Now we can go back to this and work backwards to find T naught. So now we have new stuff. TE didn't change. T naught is what we're trying to find out. The temperature with respect to time is going to be that 35. And the time is going to be 10 minutes. We know K.
Bless you.
So we're going to have 35 equals 65 plus T naught minus 65 E, running out of space, to the ln of 0.5 over 10, because when I plug this negative into that negative, it turns positive, and our time is 10 minutes.
So then can you just
So
cancel those times?
those cancel. We subtract 65. So we get negative 30 equals T naught minus 65. Now, this is E to the ln of 0.5. Punch that into your calculator, even though you should already know what it is.
Stop,
Are you
please.
serious? I was just gonna do it.
Look
just
at
to
whole
know
bunch of
what
me.
to do.
No, just this part. Punch this part into your calculator.
Yes.
It's 0.5
Because
because of the properties. Yep.
I didn't even
Exactly.
want you to hit me.
So, because of our properties, we know this is 0.5.
Good.
Like,
Dude, that is not. What is this?
So, we'll divide by 0.5.
That fixes this problem.
And we get negative 60. And we add 65. And we get 5 degrees Fahrenheit was the initial temperature.
I just don't know where you start. Like,
How to start the problem?
where you go?
Mitchell doesn't understand, then
There you go.
That's a very true statement.
That's what they are so close.
what I said?
Yo, is Walker
I
here?
messed up on the part where you divide by 10.
Mitchell, I think on these, the more you do, the more familiar you'll be with what goes where.
Okay.
So let's set up the next one together.
I wish. I understand the first half.
Okay, on this problem, I don't want anybody to interrupt me, to complain, to whine, or to talk about anything that doesn't have to do specifically with problem number 2, example A.
It's duct tape.
You can leave. Okay? So, we're sticking with the same formula.
Is this formula ever gonna change or no?
Newton's law of cooling will not change.
Alright, sweet.
Okay, so temperature with respect to time is equal to the temperature of the environment plus the initial temperature minus the temperature of the environment times E to the negative KT. Alright, so let's read this one. Suppose that a cup of soup cooled from 90 degrees to 60 degrees in 10 minutes in a room whose temperature was 20 degrees. Alright, so what is TE?
60. Oh, wait.
What is the temperature
20.
of the
20.
environment? 20. Okay?
Sorry. I was.
Alright, what would be considered the initial temperature?
690.
90. Okay, they gave us a second degree. That is the temperature with respect to time, which is 60 degrees. And the time is what? 10. Okay, we can use this information to solve for K. see if you can set up the first equation to solve for k.
Do we write it under A?
Mhm.
Each one should write the problem.
All right, did you get what I got?
Yeah, I did.
Okay, try to solve for k.
But let me see it.
I would never change it to this. Did you have this work?
I didn't write it.
Then you're right.
I'll put that in the calculator.
Okay, we won't do that until the very end. We don't change it to a decimal till the very end.
Did you divide it by a negative 2?
That causes a rounding error.
Oh, that's right. You
Compound our error.
That's how we did it. That's
40 divided by 7
And-
is
So then you
4.
just-
In your other class, you
Yeah,
changed
that's
it
all
to a decimal?
Yeah. Ooh, can I do it both ways and see what it's going to do?
That answer will be close to my answer, but my
Miss
answer will be
Closer.
more accurate.
Okay.
Yes, sir.
Is it negative 10? Is it always negative 10? Like,
No, it's because I keep using 10 minutes.
no, I know that.
If
But,
I use 5 minutes, it would be over -5.
but why is it a negative?
Because it's negative.
Because
it's
it's
negative.
-k.
We switched the T and K.
Oh,
I got it right.
I got it right too, except for that part.
All right,
I got all of it right.
now we're going to stop there, and tomorrow we're going to do the second part of this problem. Okay? So, I'm going to give you a review sheet that is not due until Friday. It's worth 10 points. It's not much bigger than a normal homework assignment, so it's kind of a gift.
Thank
Please
you.
take advantage of your gift.
It's supposed to be a gift.